Have you ever wanted to add realistic mouse and controller movements to your VNyan setup? This is now possible using the Shirohane Controller Plugin. This plugin exposes both mouse and controller parameters and keeps track of your hand's position. By combining this plugin with animated controller and mouse props and customizable animations, each button press can now be mirrored by your 3D VTuber avatar. The rest of this video goes through the setup procedures for the Shirohane Controller Plugin and how the provided props and node graphs can be configured to suit your unique 3D model. Before we begin, you will require the latest version of VNyan and the Shirohane Controller Plugin. Both can be downloaded from itch.io. Unzip the plugin and copy its contents, overwriting the VNyan folder. This will add a number of new files to your VNyan installation. Open the VNyan application and in the settings menu, scroll to the bottom of the MISC tab. Click on the Enable Third-Party Plugins checkbox. Click Yes on the pop-up to apply these settings. You will now have to restart VNyan. Once you have restarted VNyan, the Shirohane controller will appear in the plugin list. Toggle the mouse control and the interface should start responding to your mouse clicks and scroll wheel. The same can be done with the controller. Make sure a Windows-compatible controller is connected to your PC before activating the plugin. For non-Windows controllers, try running VNyan through Steam. Activate controller compatibility mode found in the Steam settings menu. The next step is to load an example avatar. 3 VSF avatar files can be found in the 3D avatar files folder, each with a different controller pose. For this example, I have loaded the M3 model. Open the prop interface and click the Add Prop button. Locate the SP mouse prop under the Item/Props folder and adjust the linked bone, position, rotation, and scale of the mouse prop. The suggested parameters for each model can be found in a table located in the user manual. Do the same with the SP controller prop, loading the prop file before adjusting the parameters. At this stage, you can load the node graphs for the selected model. Open the node graph interface and press the Add New Graph button. As I am using the M3 model, I will load the Shirohane controller node graphs located in the ID3 folder. Click the Load button and select the Shiro mouse node graph. Clicking the Rename button will ensure that the node graph is named properly. Repeat this process, loading the Shiro controller and Shiro functions node graphs. In the Shiro functions node graph, locate the controller calibration trigger. Set a controller pose using the Set Pose node, choosing a controller pose found in the Item/Poses folder. Do the same with the mouse calibration trigger, loading a mouse pose file. Now let's create activation and deactivation node graphs for the mouse and controller. In the Start Settings tab, create a trigger node named Activate Mouse and connect it to an ordered execution node. Create a core trigger node with the name sh_mouse on. This trigger will activate the mouse plugin. Use a toggle prop node to set the SP mouse prop to visible. A core trigger node with the name M3_activate mouse will start the Model 3 mouse animations. Finally, create a blend shape node, setting the sitting shape to 100. This blend shape triggers an animation built into the provided avatars, moving the clothing bones along with the model's legs. Right-click on the Activate Mouse trigger and select the Send Signal button. The M3 model will move into a sitting pose and start responding to your mouse movements. The mouse deactivation node graph has the same structure, but instead reverses the operations. sh_mouse on becomes sh_mouse off, a trigger which deactivates the mouse plugin. The toggle prop node is set to hide the SP mouse prop. The M3_deactivate mouse trigger stops the mouse animations. And finally, the sitting blend shape is set to 0. Node graphs that activate and deactivate the controller can be created following the same methodology. Create a trigger node named Activate Controller, connecting it to an ordered execution node. Create a core trigger node with the name sh_controller on, which activates the controller plugin. Use a toggle prop node to set the SP controller prop to visible, and a core trigger node with the name M3_activate controller will start the Model 3 controller animations. Activate this trigger and your avatar will move along with your controller button presses. The deactivate controller node graph consists of a core trigger node, sh_controller off, which deactivates the controller plugin, a toggle prop node which hides the SP controller prop. Lastly, a call to the M3_deactivate controller trigger, which stops the controller animations. Using these node graphs, you can move your avatar between controller and mouse modes. With the plugin installed, you can now customize the prop and node graphs to fit your avatar. I will start with the mouse setup. Turn off face tracking. For webcam users, use the VNyan settings menu. For iPhone users, put your phone into lock mode, then load your avatar. Open the node graph interface and start the Activate Mouse trigger, starting the mouse animations. Rotate and reposition the VNyan camera, focusing on the right hand of your model. A top-down view will allow you to see both the mouse prop and your model's fingers. Open the prop menu, selecting the SP mouse, and activate the Transform Mode Movement gizmo. Move the mouse prop under your avatar's hand, lining up the mouse so the scroll wheel is aligned with your avatar's middle finger. You can make smaller adjustments to the mouse position by adjusting the coordinates using the prop interface. Your model's fingers will be clipping through the mouse prop. This will be fixed by adjusting the node graphs. Open the node graph interface and select the Shiro function's node graph. Locate a trigger called Mouse Calibration. Here you can make adjustments to the little finger and thumb. Modify the bone rotation nodes so the thumb is touching the side of the mouse and the little finger is resting on top of the mouse. The index, middle, and ring fingers can be adjusted using the mouse button's trigger found in the Shiro mouse node graph. This trigger controls the mouse button clicking animations. By modifying the highlighted bone rotations, it is possible to control the held and released finger positions for each mouse click. Changing the bone rotations in the mouse button node graph will be instantly reflected by your model. Modify the release state for each finger, incrementing each finger's rotation until they no longer clip through the mouse. Then modify the held state so that your model's fingers do not clip when clicking each mouse button. A 10-degree rotation between finger states is a good starting point, but this may be smaller or larger depending on your model. You may have to repeat the process of adjusting the mouse prop and node graphs until you are satisfied with the mouse position and model movements. For example, making sure the mouse prop is touching the palm of your model's hand and adjusting the mouse click trigger for the new prop position. You can also customize the range of your model's arm movement to your screen size. Locate the Activate Mouse trigger found in the Shiro Mouse node graph. The screen size X and screen size Y parameters should be set to your screen size. The easiest way to find this is via the VNyan monitor. Open the monitor and scroll until you find the mousepos X and mousepos Y parameters. Then move your mouse to the bottom right of your screen. This value should be your screen size. In the Activate Mouse node graph, set the mousepos to screen size values and apply these settings using the Send Signal button. Your model's arm should move no matter where the cursor is on your screen. You can now use the Deactivate Mouse trigger to turn off the mouse plugin and deactivate the mouse animations. I will now go through the controller setup. Turn off face tracking. For webcam users, use the VNyan settings menu. For iPhone users, put your phone into lock mode, then load your avatar. Open the node graph interface and start the Activate Controller trigger, starting the controller animations. Open the Shiro Functions node graph, finding the arm calibration trigger. This trigger allows you to make adjustments to your model's shoulders, lower arms, and hands. Start by rotating your model's shoulders, adding adjustments evenly until the distance between your model's hands fit the controller prop. Adjust the hand rotations so your index and middle fingers are level with the controller bumper and trigger buttons. Then, rotate your lower arms to ensure your model's ring and little fingers are aligned. Open the Prop menu and using the Prop Movement gizmo, move the controller into the gap you just created. Any smaller adjustments to the controller position can be made by adjusting the coordinates using the prop interface. Your model's fingers may be clipping through the controller prop. This will be fixed by adjusting triggers in the Shiro Functions node graph. This node graph contains triggers which activate on receiving input from your controller, reacting to buttons, bumpers, triggers, and thumbsticks. I will briefly go through the operation of the 4 types of node graph triggers that you will need to modify in order to set up your controller. Each button trigger is connected to bone rotation nodes, allowing you to add rotations to your model's thumbs. In the off state, bone rotations are set so your thumb is resting above the controller button. In the on state, adjust bone rotations so your thumb is pressing the controller button. The L bumper and R bumper trigger check if a bumper button is pressed before applying either an on or off state. R trigger or L trigger monitor controller trigger buttons. If a trigger button is not being pressed, an off state is applied. If pressed, a dynamic bone rotation is calculated by multiplying the trigger pressure by the on state. By adding this bone rotation to an off state, the model's fingers can move depending on how hard the trigger button is being pressed. Moving the left or right thumbstick will activate the R stick or L stick triggers. When activated, a bone rotation is calculated based on the position of the thumbstick. By adding this rotation to the thumbstick's off state, the model's thumb moves along with the thumbstick. By modifying these triggers, you can customize the on and off finger positions for each controller input. I will now go through the procedure of modifying the Shiro functions node graph for a 3D model. Start by adjusting the right thumbstick trigger. Place your model into the thumbstick animation by moving your connected controller's right thumbstick. Adjust the y-axis of the initial right thumb position so the model's thumb is not clipping the controller. Set the offset rotation so the right thumb is centered on the right stick. The thumb should be set so it is touching the thumbstick and the range matches that of the stick's movement. Do the same with the left thumbstick, adjusting the left thumb height, range, and offset before testing the left thumbstick animation. The next step is to adjust the button trigger on the controller. Find the off trigger for the button you wish to adjust. Press the corresponding button on the controller. Adjust the bone rotation so your thumb is above the selected button. Copy over the values of the off state to the on state. Then lower the finger's Y rotation, moving the thumb so it is pressing the controller prop button. Repeat this process for each button on the controller. Move the VNyan camera so you can view the controller prop from the top, allowing you to see how your model's fingers are touching the bumper and trigger buttons. If your model's fingers are clipping through the controller prop, adjust the specific triggers. In the case of the bumper, you can modify the release and held states as described previously. For the trigger buttons, adjust the initial release position, then hold down your connected controller trigger and modify the range multiplier to control the amount of finger rotation being applied. Test the controller configuration by pressing each button on your connected controller. Your model should move between different controller button animations, allowing you to see in real time which buttons still need to be adjusted. Make sure your model cleanly presses each button on the controller prop. Once you are done with the customization, you can use the deactivate controller trigger to turn off the controller plugin and stop the controller animations. The Shirohane Controller Plugin for VNyan allows 3D VTubers to add realistic controller and mouse movements to their gaming streams. Future updates plan on adding support for additional controller types. Keep up to date with plugin development by following either my itch.io page, the Shirohane Blue Sky account, or the Shirohane Controller Plugin post on Suvi's VNyan Discord server.